Implied forward rates. The forward rate is the future interest rate that the market is pricing in today. Now the linkage is as follows. The spot rate is the geometric average of the forwards that are embedded within the spot's term. Let's illustrate this concept with an example. Suppose that we observe the following spot rates today. So for a 4-year deposit, the bank is willing to pay you 9%. And for a 5-year deposit, the bank is willing to pay you 10%. Now, the reason these are called spot rates is as follows. The entire principal and interest would be due on the expiry date. So that's why you're getting everything on the spot on the expiry date. Now, the way I like to solve these questions is with a diagram framework. And here's our timeline. So this is today. And the first deposit expires in 4 years. The second deposit expires in 5 years. And the other thing I like to do, just to keep things simple, is I like to invest $1 today and find out what will happen to this dollar at the end. So our first option is to deposit for a 4-year period, in which case we would earn 9% and then just roll it over for 1 more year. So therefore, the rate at which this is going to be rolled over would be the forward rate itself. So once you do that, in other words, invest at 9% for 4 years and then roll it over at the forward rate prevailing in year 5, you find out what your dollar is worth at the end of the 5-year period. Alternatively, if you have a 5-year horizon, the other thing you could do with your $1 is just deposit it on a 5-year certificate of deposit. And that's exactly what we have right here. So if you go to the bank and just say, look, just deposit this for 5 years and just pay me everything back in 5 years, the bank will pay you 10%, and that's exactly what we have. So $1 compounded at 10% for 5 years would tell you what your $1 is worth at the end of the 5-year period. Now here's the thing, ladies and gentlemen. Because the money markets are efficient, whether you invest your $1 for 4 years and roll it over for 1 extra year, or whether you take your $1 and just invest it for 5 years, at the end, these two approaches should have the same ending value, because in both cases, you're investing for a total of 5 years. So now what we're going to do is we're going to take this diagram framework and convert it into algebra, which will then help us solve the value for the forward rate. So first, let's have a look at some perspective. So the logic here is, by observing the spot rates available today on the 4-year and 5-year terms, we can deduce the 1-year rate that the market is pricing in for year 5. And that's exactly what we did here. So by observing the market's paying 9% on a 4-year deposit and 10% on a 5-year deposit, we can actually work backwards and find out what the market is pricing in for the forward rate to prevail in year 5, or the 1-year forward rate prevailing at the end of year 4, if you will. Now the algebra is as follows, and all the algebra is going to do, ladies and gentlemen, is we're going to take this visual framework here and convert it into an algebraic framework, and here it is. So here's my $1 growing at 9% for 4 periods, so that's exactly what you see here, growing at 9% for 4 periods, and then rolling it over at this forward rate for 1 extra period. So that gives you a total of a 5-year period. Should be equivalent, okay, to $1 compounded at 10% for 5 periods, and that's exactly what we have over there. So then when you set this up with an algebraic approach, what you see is we have one equation and one variable. So then you just solve for the forward rate. So in this case, we would refer to the forward rate as 4 years from now. So 4 years from now, what is the 1-year forward rate that's being priced in at that point in time? So that's the standard practice for indicating the positioning of the forward rate. Because when you say forward, that can mean any time in the future. So when you put these little abbreviations, it tells you, yes, we're looking at expiry 4 years, and then we're looking at the 1-year rate beyond that point. And when you solve that, so when you solve for f, which is that, you get 14.1%. So the way to interpret this is as follows. The 14.1 forward rate is the break-even reinvestment rate in year 5, such that we are indifferent between a 4-year bond or a 4-year deposit plus 1 year rollover, and simply a 5-year bond or a 5-year deposit. And you can see why it's called break-even, and that's why I love this visual framework. What would the forward rate have to be so that you would be breaking even or indifferent between a 4-year plus 1 year rollover and just a straight 5-year deposit? And that break-even rate, to make things equal between the two approaches, i.e. to break even between the two approaches, this would have to be 14.1%.